Good morning, friends. Welcome back to your favorite channel, Code One Digest. Today, in this video, we will learn what is microservice architecture, what is the difference between microservice architecture and monolithic architecture. I'll explain the use cases of microservice architecture and we'll understand the benefits of microservice architecture over monolithic architecture. So stay tuned till end of this video. There is going to be a lot of learning in this video. So keep watching Code One Digest. Friends, so here is the agenda for this video. We'll see the introduction of microservice architecture. Then we'll do introduction of monolithic architecture. We'll see the difference between microservice and monolithic architecture. Then I'll show you Java code example of microservice architecture. Then we'll understand the usage of microservice architecture. What are the use cases we have? Then we'll understand the benefits of microservice architecture. And I'll summarize the video, what we learn at the end of this. And I'll also give you a brief introduction of about my next video on microservice design patterns. So stay tuned. It is going to be exciting and there is a lot of learning in this video.
Friends, before we proceed in this video, I want you to subscribe my channel to grow Code One Digest family. Friends, I'm creating a lot of quality contents for you, but I'm not getting subscribers. I want you to like, share and subscribe my channel so that I can grow Code One Digest family. Thank you.
Let's begin, shall we?
Okay, friends. So let's start with microservice architecture. So what is microservice architecture? A microservice architecture consists of a collection of small autonomous services. Each service is a self-contained and should implement a single business capability within a bounded context. So what is bounded context? A bounded context is a natural division within a business and provides an explicit boundary within which a domain model exists. Sound complex? Don't worry, I'll simplify it. I'll explain you in simple terms. Microservices are small, independent, loosely coupled. Each service is a separate code base which can be managed by a small development team. Services can be deployed independently. A team can update an existing service without rebuilding and redeploying the entire application. Services are responsible for persisting their own data. Services communicate with each other by using well-defined APIs or internal implementation detail of each services are hidden from the other services. Microservice supports polyglot programming, like services don't need to share the same technology stack, library, or framework. Friends, let's understand microservice architecture with this diagram. So microservice architecture is an architectural style that structure an application as a collection of services that are independent, deployable, loosely coupled, organized around business capabilities, owned by small teams, and highly maintainable and testable. So if you see in this diagram, each business functionality is broken down into a small microservice, and each microservice has its own dedicated data storage. And the data sharing and synchronization between multiple services are through API calls or through some eventing platform. So if you see in this diagram, we have API gateway. The API gateway is entry point for the clients. Instead of calling services directly, client makes call to the API gateway, which forward the call to appropriate service on the backend side. Now, what advantage do we get from API gateway? So it decouples the client from a direct connection with the services, and services can be versioned or refactored without needing to update all of the client. The API gateway can perform other cross-cutting functions such as authentication, logging, SSL termination, and load balancing. Out-of-the-box policies like for the throttling, caching, transformation, and validation. Another use of API gateway is consolidating the response from multiple services and sending it back to the consumer. We call it as a aggregator pattern. So we'll see there are multiple use cases of API gateway which sits in front of our microservice architecture. Friends, now let's understand what is monolithic architecture. A monolithic architecture is a singular large computing process with one code base that couples all of the business logic together. A monolithic architecture is a traditional unified model for the design of software program. Monolithic in this context means composed all in one piece. Monolithic software component or functions are tightly coupled rather than loosely coupled. Monolithic applications are single tiered, which means multiple components are combined into one large application. Consequently, they tend to have a large code base, which can be cumbersome to manage over the time. In monolithic application, if one program component must be updated, other element may also require rewriting, and the whole application has to be recompiled and tested. The process can be time consuming and may limit the agility and the speed of software development team. Despite these issues, the approach is still in use because it does offer some advantages. So the approach cannot be completely disregarded when those applications are still in use and require updates. One of the key advantages of monolithic architecture is that it's self-contained and independent from other applications. Monolithic architecture has its drawback, including slower development speed, challenges in scalability, and in fact, that individual error can affect the entire application's availability. Now let's see a difference between monolithic and microservice architecture. Friends, now quickly understand the difference between the monolithic and microservice architecture. As we already understood the definition of monolithic and microservice architecture, let's understand non-scalability. It's very difficult to scale monolithic application because it's a big bang application running on your multiple servers. So if you want to add one more instance of your monolithic application, it takes a lot and lot of time. You have to spin up the machine, you have to set up all the softwares required for it, and then you have to install the big bang database and so on. It takes a lot of time to scale up and scale down for monolithic application. But on the contrary, with microservices, each services is an independent instance and running as a separate processes. Hence, scaling those small processes are easy compared to monolithic application. In monolithic application is having a single storage as a backend. But in microservice architecture, every microservice is having individual data storage. So the data is separated. We don't have to worry about misuse of data across the microservices. In terms of deployment, monolithic application takes lot of time and effort for the deployment. Contrary, microservice application deployment is easier, faster. We can quickly deploy, we can automate the deployment of microservice architecture. We can easily roll back. So these are some major differences we have between the microservices and monolithic application. If you see in this diagram, monolithic application having UI layer, business layer, and repository layer, all three tier packed together into a single application. And this is very tightly coupled. There is less flexibility. For a small change, we have to deploy the whole application that slow down our development cycle, our deployment time increases. So the deployment cycle of monolithic application is longer. The release cycle is very long. The business and the client have to wait for new functionality. But that's not the case with microservice architecture. We have a separate UI layer, we have a separate business layer, and each microservice has its own dedicated database. Hence, and independent teams can work on these different microservices. So we can have multiple releases across the microservices without concerning the other microservice. It is not going to impact the rest of the application if we go with the deployment of one of the microservice. Okay, friends. So now let me show you what we are going to achieve today in this Java example. So I have created a microservice application using Java Springboot framework. I'm using Springboot as a microservice framework, and I'm using Java 8 with IntelliJ IDE. So in that microservice, I'm going to create two endpoints, that is hello world and date endpoint. And I'll be calling those two endpoints from my Postman API tool. The Postman is a API testing tool where I can test these endpoints. I can call these endpoints and see the response. Now on calling these endpoints will call the business layer and then return the response back to the user. Same way, when I call the data endpoint, it will go to the business layer and get the response, send it back to the user. This whole microservice is running in a web server. We can say it is a Tomcat server. And then these endpoints are available on our HTTP protocol. It's a very simple microservice application where I have exposed the two endpoints with the two RESTful controllers, and then we'll be hitting that API through a API testing tool, that is Postman. So this is what we are trying to achieve in this demo. Okay, friends. Now let me show you a microservice project that I have created. It's a very simple microservice application where I am having a simple API to print a hello world. Okay, let me start with the pom.xml. It's a Maven project, so I have a pom.xml. In this pom.xml, I have defined the Java version that I'm using and what version of Spring Boot I'm using. So those Spring dependencies are there, but nothing fancy in this pom.xml. Only Spring dependencies are there. Then in this project, I have my main class. This is my main Spring Boot class where I have a Spring Boot application, a notation which says this is a Spring Boot application, and then I have a controller package where I have a hello controller. Okay, friends. So now let me open this controller and show you what is there inside this controller. So I have defined this hello controller as a RESTful controller, and it is having an endpoint where hello and the name of the user. So it will just reply based on the business logic that we have written in this service layer. So this is a business layer class. Let me go to this method and see what it is doing. So on passing the name, it is just returning a hello name, right? And then controller will send it back to the user. So when anybody will call this endpoint, hello Pavan, so this service layer, this business layer will return hello name. Okay, right? And same way, I have another controller, date controller, where on calling the slash date as an endpoint, it is calling the business layer class. Here in this business layer class, it is getting the current date and returning the instance of that date. So these two endpoints are defined into these two controllers, date controller and hello controller, and we have service as a business layer class. This date service is a business layer class. So both of these controllers are calling that date service to get the request processed and return the response back to the user. Now let me run this and show you how these APIs are working. We'll test this API in our Postman API tool. So now let me run this. Let's see. So it is building the application, right? Okay. And before that, let me show you what is there in my application.property. This is my configuration file. It is just having a port that on which particular port I want to run my microservice. So it is running on 8080 port. So this application.property I'm using in my local and my services are running on 8080 port. If we see here the log says the Tomcat server is started on port 8080. That means our services are available on the port 8080. Now what I'll do is I'll open the Postman and we'll test this endpoint. Okay, so my application is running. Now let me go to the Postman and we'll hit the API, the endpoint. So I have created one endpoint with a get protocol and I'm calling localhost 8080 is my port, as I shown you that I'm running the microservices on 8080 port. Then this is the endpoint hello and the name of the person. So when I hit this, yes, I got 200 response and it is returning the hello and whatever name I'm passing. Let's say if I pass a John here, so I'll get a response, hello John, right? Now I have another API, another endpoint in a date controller. So I'll be calling that endpoint, that is 8080 and slash date. If you see here, we have that in date controller slash date, right? So let me call this now. Let me hit this endpoint and see what happens. Yes, so we got the current date is equals to, this is the date, right? So this is how we have tested these two endpoints that we have written using Springboot microservices, right? So it's so simple to write the microservice application as compared to monolithic application, and then we can write as many microservices we want. We can deploy into different Tomcat servers, and we can scale up, scale down that individual microservices without impacting the whole application. So when we Okay, friends, now let's understand the success story of microservice architecture. We have few examples where they have built all their application on microservice architecture and they are very successful. They are the brand ambassador of microservice architecture. With the recent advance in the cloud technology, many big brands have now advocated moving from monolithic to microservice architecture for better functionality. Let's look at the two examples that have vastly improved their business by leveraging microservices. The first example is Amazon. We all know, we all shop with Amazon.com. If you would have looked the Amazon retail website in 2001, it essentially worked as a single monolithic application. Amazon struggled to meet the needs of its rapidly growing customer base. To solve this issue, the Amazon development team splitted the large monolithic application into smaller independent services managed and handled by a separate developer team. Amazon effort eventually led to a creation of highly decoupled service-oriented architecture that we now refer as a microservice architecture. Netflix is another example and success story of microservice architecture. Netflix started its movie streaming business in 2007 and it started facing severe scalability issue and services outage within just a year. In 2008, Netflix failed to ship DVDs to customers for 3 consecutive days. This was when they decided to switch to a distributed cloud system with Amazon Web Service as a cloud provider. Later, in 2009, Netflix began moving its application architecture from monolithic to microservices, and this process was finally completed in 2012. This move to a microservice architecture enabled Netflix to overcome its scalability challenge and offer its services to millions around the world. In 2015, Netflix API Gateway successfully processed 2 billion API requests daily. Thanks to a group of over 500 cloud hosted microservices, the cost of streaming was also reduced, which allowed Netflix to make significant financial gain. Isn't amazing?
Oh, wow. That's amazing.
So now let's understand some important tools that we use for microservice development. Building a microservice architecture requires a mix of tools and processes to perform the core building tasks and support the overall framework. Some of these tools are listed below. Like we have from a computing platform like serverless architecture, serverless tools, then we have monitoring tools, then we have orchestration tools where we manages the pods, nodes and containers. Then we have architectural frameworks that we use to build microservice application. We have toolkits, we have messaging platforms for the communication between the microservices, and then we have API management and testing tool like Postman and so on to test the individual API for each and every kind of response. Then we have programming languages. Mostly we use Java based framework or Node.js or Golang. And most of these microservices runs on Linux operating system, Ubuntu or Windows platform. So now let's understand the benefits that we get from microservice architecture on top of monolithic architecture. The microservice architecture enables the rapid, frequent, and reliable delivery of large complex applications. It also enables an organization to evolve its technology stack. Agility is another advantage of microservice architecture because microservices are deployed independently. It's easier to manage bug fixes and feature releases. You can update a service without redeploying the entire application and roll back an update if something goes wrong. In many traditional applications, if a bug is found in one part of the application, it can block the entire release process. Now, feature might be held up waiting for bug fixes to be integrated, tested, and published. Microservice architecture also supports a small code base. Not like in monolithic application, there is a tendency over time for the code dependencies to become tangled. Adding a new feature requires touching code in a lot of places. By not sharing the code or data storage, a microservice architecture minimizes dependencies and takes more, and that makes it easier to add new feature. Microservice architecture encourages the mix of technologies. The team can pick the technology that best fits their service and using a mix of technology stack as appropriate. Microservice architecture also isolate default and having a lot of fault tolerance. If an individual microservice becomes unavailable, it won't disrupt the entire application as long as an upstream microservice are designed to handle fault correctly. For example, we can implement a circuit breaker pattern. You can design your solution so that microservices communicate with each other using asynchronous messaging pattern. Scalability is another advantage of microservices. Services can be scaled independently, letting you scale out subsystem that requires more resources without scaling out the entire application. Using an orchestrator such as Kubernetes or Service Fabric, you can pick a higher density of services into a single host, which allows for more efficient utilization of the resources. Data isolation is another advantage of microservices because each microservice having its own data storage. It is much easier to perform schema updates because only a single microservice is affected. In monolithic application, schema update can become very challenging because different part of the application might also touch the same data, making any alteration to the schema risky. Now let's understand some challenges that we see with the microservice architecture. Complexity. A microservice application has more moving parts than the equivalent monolithic application. Each service is simpler, but entire system as a whole is more complex. Lack of governance. The decentralized approach to build microservices had advantages, but it can also lead to problem. You might end up with so many different languages, frameworks that the application become hard to maintain. It might be useful to put some project-wide standard in place without overly restricting teams' flexibility. This especially applies to the cross-cutting functionality such as logging. Network congestion and latency. The use of many small granular services can result in more inter-service communication. Also, if the chain of service dependencies gets too long, service A calls service B and service B calls service C, the additional latency can become a problem. You will need to design API carefully, avoid overlay chatty APIs, think about serialization format, and look for the places to use asynchronous communication pattern like queue-based load leveling. Data integrity. With each microservice is responsible for its own data persistence, as a result, data consistency can be a challenge. If two microservices want to access same domain objects, then it becomes challenge. How can we keep the data consistency, acidity, and atomicity of data? So we have some best practices defined for the microservices. They are like model services around the business domain, decentralize everything, individual team are responsible for designing and building the services, avoid sharing the code or data schemas. Data storage should be private to the service that owns the data. Use the best storage for each service and data type. Service communicate through a well-designed APIs. Avoid leaking implementation detail. API should model the domain. Avoid coupling between the services. Causes of coupling include shared database, schemas, and rigid communication protocol. Offload cross-cutting concerns such as authentication and SSL termination to the gateway. Keep domain knowledge out of the gateway. The gateway should handle and route client requests without any knowledge of the business rule or domain knowledge. Otherwise, the gateway becomes a dependency and can cause coupling between the services. Services should have loose coupling and high functional cohesion. Functions that are likely to change together should be packed and deployed together. If they reside in a separate services, those services ends up being tightly coupled because a change in one service will require updating the other service. Overly chatty communication between two services may be a symptom of tight coupling and low cohesion. Isolate the failure, use resiliency strategies to prevent failure within a service from cascading. See the resiliency pattern and designing reliable application. Okay friends, now let me summarize what we learned in this video today. So we understood what is microservices and microservice architecture. We understood the monolithic architecture. We saw the difference between monolithic and microservice architecture. We saw an example of microservice architecture. We also saw one Java code implementation of microservice architecture, and we saw the benefits of microservice architecture, also understood the challenges that we may see with the microservice architecture. We also touched upon the best practices of microservices and microservice architecture. So friends, let me know if you have already used microservices architecture in your project or seen a scenario where this architecture can be useful. So please provide your answer in the comment section of this video. Friends, in the next video, we will discuss microservice design pattern. We will learn what is microservice design patterns. We will see the classification of microservice design patterns. We will understand microservice design patterns in detail. We'll deep dive into each and every design patterns and we'll understand those design patterns with an example. We understand the problem statement and then we'll provide a solution and how, where, and what we can use to solve the problem in microservice architecture. So stay tuned for the next video and do subscribe to the channel if you're new to the channel to grow Code Digest family. Thank
Friends,
you.
if you like this video, so give it a thumbs up and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners, and software engineers. I am putting a lot of efforts in creating these contents, so please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.